Hello guys, welcome back to Meson African Motives, still on our revisions for mathematics N3. So this is actually a video that is being sponsored by our members of the Meson African Motives. If you have questions or topics that you want us to work on, please just join membership so that you have access to the questions that we can work on as a family or that we can do. So that can actually help us also to grow as a family. So I'm not going to waste much time. This is August 2023 exam mathematics N3 full paper revision that we're going to have. All right, so here I'm just going to quickly rush through the questions. It's a scanty paper that I just got from you guys. So I just hope it's clear enough so that we can be able to attempt these questions together. All right, so the first part on question number 1 was to factorize 1.1, factorize each of the following as far as possible. All right, as far as possible in prime factors and simplify the answers. All right, so that's it. We've got 3 marks for the first question. I'm just going to write this question aside here so that we can now properly see our question. So that was 1.11. So this is 1.11. All right, so let us just have this, which is we are given AB to the power of 2 minus B into M. So that's we've got a negative B, so that's plus M into 1 minus AB like this. Okay. So the question is, if we are to check what we have actually here, we know that we are supposed to factorize in a way that the two brackets will be actually the same, like what we have and the first part and what we're going to have on the second part will be the same. So if we are to check here, there are so many ways that we can actually apply, because already the second bracket here, we have it as 1 minus AB. So what we're going to simply ask ourselves is that what can we do in this case to obtain 1 minus AB? Not AB minus 1, but 1 minus AB. So if we are to check here, if we are to factor out a B, I want you to see what was going to happen. If we factor out a B, this was going to be, if I factor out a B, this was going to be AB minus B. If we factor out B, we're going to divide B squared, and B cancels, going to be a B. All right, that's a negative 1, not negative B here. Negative 1. It's going to B and B will cancel, so it will be a negative 1, which is AB minus 1 and 1 minus AB. They are two different terms. It's not the same. So in order for us to have this 1 as a positive and this AB as a negative, it means we are supposed to factor out a negative B. The moment I factor out a negative B here, this will be a negative. So I'm going to obtain positive and negative, which is going to be negative AB. Negative and a negative will give us a positive, so it will be positive 1. Okay, so this bracket that we see and the bracket of 1 minus AB, the question is, are they the same? That's the question. It's like I'm writing 1 minus 2, and the other one is writing minus 2 plus 1. These two are the same. But it's different to say 1 minus 2 like this, and we say 2 minus 1. Now this is different. Like what we have here. AB is supposed to be a negative. 1 is supposed to be a positive, just like this part. AB, it's a negative. 1 here, it's a positive, just like what we have on the other bracket. So it means these two brackets are the same. So we know that if these two brackets are the same, we are going to factor out the common bracket, which is 1 minus AB, because they are the same. To write minus AB plus 1 and to write 1 minus AB is the same. So that's why I'm factoring out this bracket. So here I'm going to remain with a negative B. Here I'm going to remain with a positive M. Remember, if you factor out the common bracket, you have to divide by that common bracket. So that's we're going to have 1 minus AB into M minus B. All right, which is one and the same thing as this part. Remember what I was explaining on this part. So like I said, this was a question which was in your hands, and you can do whatever that you want to factorize. If you wanted to, like some of us could, okay, let me just expand the brackets and see what's going to happen. All right, That's going to be AB squared minus B. I expand here, that will be a plus M. I expand here, that will be minus MAB. All right. So the question is, we've got an AB here, we've got an AB there. All right, so what can we do? We can just rearrange AB squared minus B like this, all right? Then we take this AB to start on this part. So it's gonna be minus AB plus M like this, okay? So the question is, this is just an arrangement that we can do to say, since we've expanded the brackets and you want to see how all your terms are going to correspond, if you factor out for the first two terms, you see, okay, there's something common, which is B, and here there's something common, which is M, but here I'm having A, B squared. So let me just start the other part with AB. Not to say, even if you're to maintain as it is not going to give us the correct answer. You're still going to have the same answer, but for simplification purposes, if you don't want to have a confusion, that's the best way that you're going to have. So here on the first two, by grouping, I'm going to factor out the common bracket, the common term between these two, which is B. So if I factor out B, I divide. So it's going to be AB squared divided by B, which is going to be AB in this case, minus B divided by B. That will be a -1. B and B cancels, so it will be a -1. So we want to factor out this part of our bracket or this part of our expression so that we obtain the same bracket as AB minus 1. Here, if we factor out M, this one is going to be minus AB. So in order for us to have it as a positive AB, we are supposed to factor out a negative. So we are going to factor out negative M. The moment I factor out negative M, it means this will cancel minus M, and minus M will cancel. Here I'll remain with positive AB. Then if I divide plus and the minus, it will give us a negative M, and M will cancel. That will be a 1. So as you can see, the first bracket and the second bracket are common, are the same. So you can factor out that common bracket, which is the AB minus 1. If I factor out this common bracket here, I'm going to remain here with a B. Here, I'm going to remain with a negative M. So this answer that we see of AB minus 1 and this answer of 1 minus AB, they are different in terms of writing here to say, this bracket here of AB minus 1 and this bracket of 1 minus AB, they are not the same, they are different. M minus B and B minus M, they are not the same, they're different. But in terms of our simplification, these two answers, they're correct. We applied the correct procedure, even though we see our answers to be different, we are having the same thing or the same part that we had before. If you want this to be the same, so many things, we're going to factor out a negative, which is going to be another step to check if these two answers are the same. All right, but I just hope we understand this, just a revision. I just hope we are revising. We are not doing a topic here. We're just going to have a revision. The second part was to factorize, and this was a tricky thing, tricky type of a question. Let's see what were they trying to do here. All right, so that's question 1.12, where we have got x to the exponent of 4 minus 2x to the exponent of 3 minus 3x to the exponent of 2 plus 4x in this case. So we've got plus 4x plus 2 like this. This is what we're given. That's what we're given. So the question is, how many terms do we have here? 5 terms. 1, 2, 3, 4, 5. This is that type of a difficult question. But anyways, if we are to check here, I want you to get back to your expressions, all right? I want you to understand this question. So I just want to take you back to expressions. When you are given to factorize x squared plus 2x plus 1 like this, okay? This is called a quadratic equation. So, I mean, a quadratic expression. You can factorize this quadratic expression by just checking, okay, here I'm going to have the x squared, the factors of 1, because the coefficient of x squared, I talked about this factorization, is the 1. So I'm just going to have 2 brackets, x and x here. Factors of 1, which will give us a 2, which is 1 and 1. I'm done. If this was maybe a negative, I've got x squared. Maybe I've got negative here. Let us just have negative x. Let's say I've got negative x plus 2. You're asking yourself, okay, here I'm having the coefficient of x squared, which is 1. I'm have 2 brackets, x and x. Here I'm going to have a plus 2. So you're going to ask yourself factors of plus 2. That will give us a positive 1. So this cannot give us a positive 1. So this was supposed to be a negative 2, a negative 2, so that it can make sense. So factors of negative 2, that will give us a negative 1. So we've got a negative 2 and positive 1. So this will be negative 2, this will be positive 1. We are used to this type of factorization on a quadratic expression. But it is the same scenario that we can also have. I want you to check, guys. They are just playing with us. Let us say we've got a x here. I'm just going to write this. I'm going to square this, and also I'm going to square this. So if I square here, I'm going to have x to the exponent of 4. 2 times 2, that's 4. Minus x to the exponent, here it's a 1. 1 times 2, that will be 2. Minus 2 like this. It is the same situation that we see. We can have this as a quadratic expression, that we had of x squared, because x to the exponent of 4 can be written as x squared to the exponent of 2 minus the x squared that we see here is the same as this one that we see here, the x squared. So we're just going to write this as it is, which is minus x squared minus 2. So as we can see, it's a quadratic expression. We are talking about this term being the same, x squared and x squared. Just like here, we've got x and we also have x. We've got x and we also have x. And this term is being raised to the power of 2. So it's a quadratic expression. So we can factorize the same way that we have been factorizing our quadratic to say, if this is being x squared to the exponent of 2, so my bracket is going to be x squared in one bracket, another bracket is going to be x squared. Then we focus on this negative 2. What are the factors of 2? Which will give us a negative 1. We've got negative 2 and negative 1. So that will be negative 2 and a positive 1. So meaning to say this quadratic expression of this nature can be factorized this way. So that is the same scenario they were hiding here. Here, they are hiding a quadratic expression from x to the exponent of 4. We must have x squared and we must have a constant so that we can be able to factorize. So how can we have this in form of this format that I'm explaining? We're gonna have to rearrange in this case. So we are going to rearrange our terms. So that will be x to the exponent of 4. We take the part that is being raised to the exponent of 2. That is the one that we need, which is minus 3x squared. So we took this term and this term. And the next thing is a constant. And our constant here is plus 2. So this is what we're going to have. So this part that we see here can be factorized in this way. We can apply this type of factorization like I was explaining from the normal factorization of this nature. But the remaining part, as we can see, we are going to remain with minus 2x cubed. After taking this term, and this term, we're going to remain with minus 2x cubed and positive 4x. These are the terms that will remain. We are not going to consider this because the moment you consider this part, we cannot factorize it. So we are just going to write it at the end, minus 2x cubed and the 4x. So this, I'm just going to write it here, minus 2x to the exponent of 3 plus 4x. All right, there's something happening between these terms. This part here, I explained, this is the part that I was explaining. So this here simply gives us the normal quadratic expression that we are used to, whereby we can write this x to the exponent of 4, this one, as x to the exponent of 2 to the exponent of 2, minus 3x squared plus 2. So as you can see, we've got this term and this term being the same, just like this part and this part, or just like the part of having x and x. So meaning to say, we can apply our factorization in this case, but having the bracket, so you're going to have, we're going to factorize up to this term. We are going to factorize up to this term, all right? So that will be the first bracket. All right, let's just have an equal to here. So we're going to have two brackets. The first bracket, just like this part, is going to be taken from the x squared that we see, which is the same here. So you're going to have x squared and x squared. We focus on the constant. So you're asking yourself, what are the factors of 2? But these factors of 2 should give us negative 3. We have factors, 2 numbers that you multiply to get positive 2. If you multiply those numbers, they will give you a positive 2. But adding those numbers, if you add them, they will give you a negative 3. So we've got negative 2 and negative 1. If you multiply this, we get a positive 2. If we add these numbers, we get a negative 3. So meaning to say, we're going to have negative 2, negative 1. That is what we're going to have from the factorization of this expression. But as you can see, we are left with these two here. We are left with these two terms. So on these two terms, we can just factor out because you can see that there's a common term here. So it's going to depend, are you going to factor it out as a negative or as a positive? So in order for this x, the first term of x to be positive, we are going to factor it as a negative. So on the last two terms, these ones, you are going to factor out what is common. There is common, there's x, 2, there's 2. In 4, there's 2. So meaning to say, we can factor out negative 2x. The moment we factor out negative 2x, that means we're going to divide negative 2x into this. So that's negative 2x cubed divided by 2x is going to be a positive x squared there, because we've got something like this, negative 2x cubed divided by negative 2x. So that will cancel, and this will be x squared. So you're going to remain here with x squared. Positive 4x divided to negative 2x. So we've got positive 4x and negative 2x. So this will cancel. 4 divided by negative 2, it will be a negative 2. So after factorizing from these two brackets that from these two terms that we were having here, these two terms here, we have factorized these two terms, we got this part. We can see that, all right, this part here is common. It's now an expression. This whole term is an expression because it's being separated by a minus. It can be separated by a plus. So it means we have got a term up to this, it's a term. Up to this, it's a term. So between these, we can see that, all right, this part, this part of x squared minus 2 and this part of x squared minus 2, they are common. So if they are common, we're going to factor out the common term, x squared minus 2. Just like the previous part, if we factor out x squared minus 2, we're going to remain here, we divide, so we're going to remain with x squared minus 1. So we're going to have x squared minus 1. If we factor out x squared minus 2 here, we have removed this, we are going to remain with what? With negative 2x. That is the term that we are going to remain with. So we are going to remain with the negative 2x like this. So that means we've got a bracket of x squared minus 2. And here we're going to have x squared minus 2x minus 1. All right. So that is what we're going to have. And as you can see, it's a quadratic expression, this one that we're getting. So you're supposed to test it again. Is it possible for us to factorize here? We consider the equivalent of x squared being a 1. So we're going to try and see if we can be able to factorize this expression. Just like this part, remember I talked about this part of x squared plus 2x and so forth. So let us try x squared minus 2x minus 1. You're going to have two brackets, x and x here. So what are the factors of 1? But these factors give us negative 2. So as you can see, we do not have that. Negative 1 and 1. These are the factors of negative 1. If we multiply this, we get negative 1. If we add this, we get a 0, not a negative 2. So meaning to say this term cannot be factorized. So if it cannot be factorized, it means we are done. This will be our final answer. We can't factorize this any further. We are at the last stage of our simplification. That is to simplify as far as possible. So these are just examples or illustrations. Don't consider these, guys. I'm just illustrating to say how it is supposed to be like from the normal sense of our factorization. So don't consider this. All right, so just hope it's clear. How many marks for that? 4 marks, which is fine, which is actually fine. Question 1.3 are given, determine the value of p if f of x, this f of x that we see here, it gives a remainder of 10 if divided by 2x plus 1. It gives us a remainder of what? It gives us a remainder of 10 when divided by this. All right, so let us just take our cubic expression here. All right, so I'm just going to remove this part here. All right, so our cubic expression, that's question 1.2. We are asked to determine the value of p for which if f of x, all right, our f of x is equal to 6x cubed plus 4x squared plus px plus 3. That was our f of x in this case. So they are saying we are supposed to determine the value of p if this expression gives a remainder of 10. So you're given the remainder of what? Of 10 when divided by 2x plus 1. When divided by 2x plus 1. What is going to be the value of p? Remember, I talked about factor and remainder theorem to say for a factor theorem, if you consider this part that is divided, we are dividing by 2x plus 1. I just want you to see the one thing that is important there. the part that you are dividing with, you are dividing by 2x plus 1. All right, just equate that part to 0. All right, whether it's a factor or it's a remainder, equate that to 0. 2x plus 1 is equal to 0. You get the value of x. So x is going to be -1 on that side. Then we divide by 2. So that means x will be a -half. So I want you to be careful. This value of x is going to give us two things. When it is a factor, if you are considering to be a factor, it means f of -half must be equal to 0 when it is a factor. But when it is given a condition of a remainder, the f of same -half that gave us a 0 when it was a factor, it is going to be equal to the remainder this time. So when you are given a remainder, it means f of this value is equal to the remainder. But when they say it's a factor, find the value of p when this one is a factor, when 2x plus 1 is a factor, you are going to equate f of -half to 0. The same x that you are talking about, which you are equating to the remainder now, because they said it gives us a remainder of what? It gives us a remainder of 10. So it means we are going to use the remainder concept to say f of -half should be equal to the remainder in this case. And our remainder is what? Our remainder is a 10. So that's an equation that you have formulated. By just having this, you are telling us that this is an equation whereby I'm supposed to substitute f of -half. It means wherever there is x, wherever you see x, you substitute a -half. So here there's x, so it's going to be 6 into a -half to the exponent of 3 plus 4 into a -half to the exponent of 2 in this case, plus px. So our x there, it's a -half. So it's going to be -half p because it's plus px. So x being -half and the plus, it's a negative. So it will be -half p plus 3. We can't substitute anything here. So it will be just a plus 3. So this is our f of -half. We substituted half wherever there's x, we are putting this -half. But we are saying, since they said it gives us a remainder of 10, this must be equal to the remainder. And our remainder there is a 10. So this must be equal to 10. So you can solve for p. As you can see, it's an equation that we have formed. So you can solve for p. Let's say they said it's a factor. This one we're going to equate to 0. But this one is not a factor because it gives us what? A remainder. So what I want you to do on your calculator, simplify this part and this part and this part, combine them together. All right, let us just do this together so that we can also see what I'm saying here. So I'm just going to put the calculator here so that we can see what I'm trying to say. So that's our calculator there. So you're just going to have, all right, that's 6 into -half, 6 into -half. So that's a -half like this to the exponent of 3. All right. So you combine this plus a 4 plus 4 into a -half like this to the exponent of 2. Okay. Then we've got a 3. So you're going to add our 3 here, which is 13 over 14. So we are going to obtain 13 over 14. This is what we are obtaining from combining the numbers. But remember, there is a -half p that we did not include when simplifying these numbers here. So there is a -half p that we have. And this must be equal to what? This must be equal to a +10. All right, so that's it. We can solve for p in this case here. We can solve for p. It's either you can transpose the 13 over 4 to the other side of the equation so that it can be a negative. So that will be -half p is equal to, remember this was a positive, so on the other side it will be a negative. So just on your calculator, simplify here on our calculator, just gonna simplify 10 minus 13 over 4, which is that answer that we got before. So that will be a positive 27 over 4 in this case. So you're going to obtain positive 27 over 4. So that's positive 27 over 4 like this. So in order for us to have the value of p, since we are multiplying by a negative half here, we are going to divide by a negative half both sides. So p is going to be 27 over 4 divided by negative half. All right, so this answer here divided to a negative half in this case like this. That is going to give us negative 27 over 2. So we're going to obtain negative 27 over 2, or as a decimal, negative 27 over 2 is the same as what? Is the same as negative 13,5. So there we are going to obtain negative 13,5 or negative 27 over 2, or p is equal to negative 13,5 in another way of writing this answer, and this answer just the same. All right, so that is how our questions might be given as. This is how our questions might be given as factor and remainder theory. Like I said, for a factor, f of this value that you are given, whatever value that you are given, the f of that value must be equal to what? Must be equal to 0 when it is a factor. But when it is equal to remainder, f of that x that you obtained must be equal to the remainder. That's the concept of our factor and remainder theorem. 5 marks for that. All right, determine this was 5 marks. Then simplify the following expression on 1.3, which is 7 marks. All right, let's see how 7 marks. All right, let us just see. All right, let us just see 7 marks for this. Okay, let's see. Why are we supposed to obtain the 7 marks there? All right, that was question 1.3. I'm just gonna rewrite down so that we properly see our question. It was given as b squared plus 3b plus 2 into b plus 2 like this. Everything is over 2b squared plus b minus 3. All right, being multiplied to 4b squared minus 9 over 9b plus 36 multiplied to 1 minus 2b plus b squared, everything over 2b to the exponent of 2 minus 5b plus 3. That was the whole expression under a multiplication, and I have to simplify. 7 marks for that. All right, as you can see, everything is under multiplication. So all we just need here is to factorize. That's it. We just have to factorize and see what's going to happen after that. All right, so let us just try and simplify. Stage by stage. So okay, just for the sake of time, I'm just going to write these aside, and you're supposed to show these calculations. You're not supposed like to erase them. You're supposed to show them aside, but yet let's just save them aside. Here they just want to trick us here, because if you can check here, the moment you just expand your brackets, there's something happening here. B squared plus 3b, because if you say here, because there is b plus 2, so I'm going to factor out b here, we are not going to have the same thing, because the moment, let's say you wanted to factor out b here, the moment you wanted to factor out b, it was going to be b plus 3 like this. B and b will cancel, so it will be b plus 3, not b plus 2, but b plus 3. And these two, they are different. So it means it was impossible for us to say, because if there's a bracket here, let me factorize these two terms. It's impossible. So what we can do was to expand the brackets. 2 times b here, it was going to give us 2b. 2 times 2 here, which was going to be a positive 4. So as you can see, these are like terms. So it's going to be b squared plus 2 times 3 plus 2, which is 5b plus 4. So we are back now to our normal factorization. Our normal factorization that we understand, if that is 1, so you're going to have 2 brackets here. So the first one is going to be a b, the other one is going to be a b. Then we consider factors of 4. What are the factors of 4 that's going to add up to 5? We have 2 numbers that we multiply, they give us a 4. But these numbers, if we add them, they give us a 1. So that's 4. They give us a 5. So that's 4 and 1. 4 times 1, that's a 4. 4 plus 1, that's a 5. So meaning to say we are considering 4 and 1. If we multiply these 2 numbers, we get a 4. If we add, we get a 5. So it's going to be 4 and 1. So that's plus 4 here, plus 1. So as you can see, this whole part here being simplified, it is going to give us these 2 brackets. That is, we are going to obtain b plus 4 into b plus 1. All right, everything over, we've got a quadratic that we need to factorize again. All right, so this one is a different type of a quadratic expression, because here the coefficient of x squared is not a 1, it's a 2. So you're going to just apply the longer way. Yes, there's a shorter way, but that shorter way, most of us, we seem to have difficulties in using that. So that's why I prefer you to use the longer way, whereby you simply multiply the first term and the last term. So you're going to multiply these two terms here, 2b squared times negative 3. So it's 2b squared times negative 3, which is going to give us negative 6b squared. So you're going to need two factors now that we multiply to get this term of negative 6b squared. All right. But these two numbers must add up or give us a positive b. We are considering b now. We are considering b as it is, not to say a 1. Yes, it's a 1, but it's 1b. So meaning to say the terms that you're going to consider here is going to be 3b and negative 2b. If I multiply these two numbers here, 3 times negative 2, that's a negative 6. If I add 3 plus negative 2, that's positive 1. If I add these two numbers, I'm going to obtain positive 1. So these are the two terms that I'm going to replace into the middle term. So in place of this b that we see here, we're going to substitute these two terms. So it will be 2b squared. We substitute 3b and negative 2b like that. So as you can see, we now have 4 terms. And if you've got 4 terms, group them into 2 so that you can factor out what is common, which is b. So the moment I factor out a b here, it will be 2b squared divided by b, which is 2b. 3b divided by b, which is going to be a 1, 3b. It's going to be 3 there because it's 3b over b like this. This will cancel. All right. So it will be a positive 3. All right. The same thing, we are supposed to obtain the bracket of 2b plus 3. But here it's negative 2b, negative 3. So what can we do so that it will be a positive? Every term must be a positive. So you're supposed to factor out negative 1. Negative 2b divided by negative 1, it will be a positive 2b. Negative 3 divided by negative 1 is going to be a positive 3. So as you can see, these two brackets are the same or they are common. So you're going to simply factor out the bracket of 2b plus 3. And what are we remaining with? If we factor out 2b plus 3 here, we're going to remain with b. Here, we're going to remain with a negative 1. So meaning to say the first part is going to have a b. The second part is going to have a negative 1. So these are the two terms that you're going to have in the cell in the other bracket, b and minus 1, b minus 1 and 2b plus 3. So this is what you're going to have here, 2b plus 3. So you're going to have 2b plus 3 into b minus 1. So that's b minus 1 like this. All right. Let's move on to another term. We are given in this case 4b squared minus 9. This is a difference of two squares. As we're going to see, guys, we just need two brackets where we're going to have the square roots of this term, the square root of 4, the square root of b squared, which is 2b, the square root of 9, which is 3. So one is going to add, another one is going to subtract. All right, that's a difference of two squares. 9b plus 36, yeah, just factor out the common term, which is 9. 9b divided by 9 is going to be a b. 36 divided by 9, which is b, a 4. If we divide that, it's going to give us a 4. So there's direct. Then on this part, they wanted to test you guys here on this one. Actually, that's why it was 7 marks. There's a lot here, but it's not that much. It's not that lot. It's just that they just wanted to play with us. Yeah, a lot of things that you just need to consider. All right, we've got 1 minus 2b plus b squared. Yes, we can factorize as it is, but it is best for us to just interchange and start with the b. B is a positive, and let us just start with b. So you're going to have b squared minus 2b plus 1. As you can see, back to that normal expression or our normal algebraic expression. Sorry for that, guys. Our normal algebraic expression that we are used to, whereby we just have two brackets in this case. So we're just going to need two brackets. I think this one you can just write it direct, guys. All right, let's just write this direct because here it's direct. All right, so you're going to multiply here. You're going to have two brackets. So like I said, when I need two brackets, since here the coefficient of b squared, it's 1. So you're going to have b and b. All right, what are the factors of 1? But we add that to get or to give us a negative 2. So you need factors of 1, which will be negative 1 and negative 1. If we multiply this, we get a positive 1. If we add these two, we get negative 2. So we've got negative 1 and negative 1. So this would be negative 1, negative 1. Okay. Then we've got another quadratic, just like the previous part, this one of 2b squared plus b minus 3. We have another condition, but this one is given as 2b squared minus 5b plus 3. So you're going to apply the longer way since the coefficient of x squared of b squared is not a 1. So you're going to multiply these two, 2b squared times 3, which is going to be 6b squared. So do we have factors of 6b squared that we're going to add, and they will give us a negative 5b. So we need factors, but if we add them, they must give us a negative 5b. We've got negative 3b and negative 2b. Let's consider this. If we multiply this, we get a positive. If we add these two numbers, we get a negative 5. So these are the terms that I want here. So I'm just going to substitute into the middle term. I'm going to have 2b squared. In place of negative 5b, I'm going to have minus 3b and minus 2b. Since here I'm having 2b, it's best for me to start with a negative 2b. Here I'm having 3 at the end. So it's best for me to have also 3 at the end here. So I'm just going to have minus 3b plus 3. All right. Not to say if you start with negative 3b here, you're not going to have the same answer. You're going to have the same answer, guys. You're just going to have the same answer there. All right. Let us factorize. Since we've got 4 terms, going to group them into 2. Factor out what is common here, which is 2b squared divided by 2b. 2 and 2 cancel, b squared and b. So that will be a b there. Minus 2b and 2b cancel, that will be a negative 1. So in order for us to obtain b here and here to obtain a negative 1, we must factor out negative 3, not positive 3, so that negative 3b divided to negative 3, negative and negative will cancel. So it will be a positive b. Positive 3 and negative 3 will cancel and give us a negative because this was a positive. So it will be a negative 1. So as we can see, the two brackets are the same. We've got the bracket here of b minus 1, the bracket of b minus 1. So you're going to have b minus 1. What are we going to remain with here? 2b. What about here? Minus 3. So you're going to remain with 2b minus 3. So that is what you are going to obtain. B minus 1 into 2b minus 3. All right, so that's b minus 1 here. So if everything is over b minus 1 into this will be 2b minus 3. All right, so that's 2b minus 3. All right, it was just hectic factorization throughout, but thank God we are done. We have factorized every term. Now what we're going to do, we are going to cancel. The concept is between the numerator and denominator. Remember, as long it is from the numerator and the denominator, we can cancel that. Just like b plus 4 here and b plus 4, we can cancel that. We've got b minus 1, we've got b minus 1. We've got b minus 1 here, we've got b minus 1 again. 2b minus 3, we've got 2b minus 3. 2b plus 3, we've got 2b plus 3. Guys, we canceled almost everything, but we are left with something here on top. On top, we are left with b plus 1. Down here in the denominator, we are left with a 9. So the answer is going to be on top. Like I see, we are left with b plus 1. In the denominator here, we are left with a 9. So it's going to be b plus 1 over 9. Just leave your answer like that. All right, that was it. 7 marks for that. Okay, tell me what you think, guys. Tell me what you think on the comment section. 19 marks for this question number 1. Everything there was 19 marks, which is fine. But let's talk. Let's see. Solve the following equations. 4 marks for the first one. What was the tricky part of this equation that they? Okay, let's see. Let's see our equation. I'm just going to rewrite our equation here. All right, so that we see how we're supposed to attempt this. So this is question 2.1. We were asked to solve the equation. And 2.11, we are given the square root of 2x plus 1 that was being added to 2 into the square root of 2x minus 1. All right. Into the square root, all right, over the square root of 2x plus 1 plus the square root of 2x minus 1, 2x minus 1 plus x. This is equal to 1. Solve for x. All right, let's see. All right, what can we do here? What can we do? What if I cross multiply? Because this is a fraction, they just want to play crazy games with us here. In this department, they do try. These guys of department, they do try just to play around with us. They try, but they fail at the end because we know them. We know them that they're gonna just cross multiply. And easy thing, that's what they tested you there. Because 1 is same as 1 over 1. So you're just gonna cross multiply. 1 times this is gonna multiply this whole part. So it's just going to remain as it is, meaning to say you're going to remain with the square root of 2x plus 1 plus 2 into the square root of 2x minus 1 equal to, we cross multiply, 1 is going to multiply everything on this part here. These guys, they are not clever. All right, anyways, they tried, but they tried to scare us here. They tried to scare us. They wanted to scare us here. All right, they wanted to scare us. All right, so if cross multiply there, this one multiplies here, this one multiplies here. So after squaring everything, we can see, all right, they are like terms, because like terms, guys, it's like if I have x squared and x squared, these are like terms. So you can be able to add, if this is 3, 1 plus 3 is which is going to be 4x squared. It's possible to do that. These are like terms, just like the square root. The square root of 2x plus 1 is a like term to the square root of 2x plus 1. So the moment I take this to the other side, it's going to subtract and it will cancel because it will be a 0. So this will be, I want you to see what's going to happen. If you take this to the other side, it's going to cancel because you'll be left with the square root of 2x plus 1 minus the square root of 2x plus 1. All right, here we've got plus 2 into the square root of 2x minus 1. We also take this one, this side, it becomes a negative, the square root of 2x minus 1. All right, the x, let's just leave it for the meantime, this side, because we do not know what is going to happen with this x. It's not under the square root, remember? So like I said, these are like terms. So this one and this one can cancel. What about this? This is a 1, so it's 2 minus 1. These two are the same. The square root of this term and the square root of this term, these are like terms. So you're going to subtract 2 minus 1 here, which is going to give us 1 square root of 2x minus 1. But 1 square root of 2x minus 1 is same as what? Is same as 2x minus 1, which is equal to x. So we've got the square root of 2x minus 1, which is equal to x at the end. And this is the normal type of equation that we are used to. Now they are avoiding to do that. You see how they're avoiding. They just want to give those frightening expressions, this and that. At the end, they know that these things will cancel at the end. So just frightening. All right. Anyways, guys, how do you solve this equation at this stage? We can remove the square root by squaring both sides. So the moment we square both sides, we have removed the square root. So it will be 2x minus 1 is equal to x squared. So this will be x squared. That's a quadratic equation now because the highest exponent here is 2. So I can just transpose my all terms to the right-hand side. So 0 is equal to x squared. 2x to that side would be negative 2x. Negative 1 to that side is going to be a positive 1. So we are left with a normal quadratic equation that we can solve. X squared minus 2x plus 1, which is equal to 0, is same as 0 is equal to this. So as you can see here, we can simply factorize and equate to 0 in this case. So here we're going to consider the factors of 1, which will give us a negative 2. So two numbers, we multiply them, we get a 1. But these numbers should give us a negative 2. It means it must be negative 1, negative 1. Negative 1 times negative 1, it's positive 1. Negative 1 plus negative 1, it's a negative 2. So here we've got a negative 1, here we've got a negative 1. So from the 0 concept, it follows that each bracket must be equal to 0. So it's either x minus 1 must be equal to 0, or the other bracket of x minus 1 must be equal to 0. So that means we are going to have x is equal to 1 in this case. Here we are going to have x is equal to 1, or here we're going to have also x is equal to 1. So that's x is equal to 1 is the solution here, because we are obtaining the same answer throughout. We are obtaining the same answer. All right, so look how they just try to scare us. So here we're just supposed to cross multiply. After that, collect like terms. As you can see, some of the terms, they are canceling each other as we are collecting our like terms. Then from there, once you are left with a single square root, the single square root equal to x, with that single square root, you now square both sides. The moment you square both sides, you are removing the square root. You are now left with a quadratic equation. Solve your quadratic equation the normal way that you are used to. All right, question 2.12, a logarithm. All right, a logarithm. Again, how many marks that? 5 marks. So let us just consider our log function, and the log, most of the times, it brings us hectic solution at the end, but you're supposed to get used to that. All right, so that was question 2.12, which is a logarithm, whereby we're given the logarithm of x in base of 3 is equal to 2 plus the logarithm of, all right, that's 15 there, the logarithm of 3 in base of x. All right, they tried again. Here they're just playing around with this concept here. I want you to see from your formula sheet here, there's this part here, they play around with us most of the time of the change of bases. It's something that we know. Did I insert the formula sheet here? I think I forgot to insert the formula sheet. All right, there's another page there, because I think I've got a formula sheet. Oh, there it is. I want you to see here one or two things here. This one. There's this law that I want you to see here on the logarithms. This one is the one they want us these days to play around with. They do try by all means to repeat this. Logarithm of a in base of b can be written as 1 over log b base a. Why are we considering this? All right, because these two, they are different. All right, let me show you something. These two, they are different, because someone will be thinking that these two, they are the same. No, they are different, these two terms here that we see. This is log x base 3. This is log 3 base x. They are different. So how can we either write this as log x base 3? It's only from log a base b, which we can change as 1 over the logarithm of b in base of a. So as you can see, the moment we introduce 1 over from that law that we saw, these two, they interchange. So it was a base b, now it's b base a. So it's either we are going to change this to be the same as this one, or we are going to change this one to be the same as this one. It's up to you. It's your choice, this one. So I do not know which part are you going to change, but it's best for you to maintain log unknown of the and the base. It's best for you to maintain log x. We are used to, not to say x is on the base. I'm not saying you can use that and not obtain the same answer. No, you can have the same answer, but we are used to have a condition of log a base 2 log x base 3, and we are used to that normality. So let us just leave this, all right, as it is. The logarithm of x in base of 3 is equal to 2 plus, so I'm going to change this, the logarithm of 3 in base of x, to be the same as what? As the logarithm of x in base of 3. How is that possible? I'm just going to introduce 1 over. The moment I write this as 1 over like this, it changes everything. It changes everything here. So these two interchange. So it will be the logarithm of x in base of 3. The moment you introduce 1 over, these two, they interchange. Just like a base b is b base a, it is interchanged because of 1 over. So as you can see, this is now just a normal fraction. What we just want is to have this log x base 3, log x base 3. That is what we want for now. That is the most important part for now. To have the same writing, not to say, yeah, there's log 3 base x, there's log x base 3. No. So as you can see, this is a fraction. We are now having a fraction. So let's consider clearing the fraction. We're going to multiply by the LCM. This is same as over 1. This is same as over 1. So we're going to multiply by the LCM of the denominators, which is the logarithm of x in base of 3. We also multiply here by the logarithm of x in base of 3. We also multiply here by the logarithm of x in base of 3. So let's multiply. The logarithm of x in base of 3 times the logarithm of x in base of 3, it was supposed to give us log squared x in base of 3. But the writing and the formality there, let us just write it. It's just like 2x plus 3 squared, where we have got two brackets of 2x and 2x multiplying each other. It's the same concept. So you can just write it as the logarithm of x in base of 3 to the exponent of 2. So this here simply means we've got the logarithm of x in base of 3 to the exponent of 2. All right, which is equal to here 1, and this just 1 into 2, it's 2. So it's going to be 2, the logarithm of x in base of 3 here. All right, this part where we multiplied is going to cancel because this will be like over 1. So the log x base 3 log x, remember that was the condition, the concept for us to remove the fraction. We multiplied by the LCM. The moment it multiplies here, we remove the fraction. So this will be a 1. 1 times 15 is going to be a 15. So as you can see, guys, this is a normal equation that we are given, but it's a quadratic equation since the highest exponent that we see here, it's a what? It's a 2. So we're going to transpose this to the other hand. It becomes a negative. So that's negative 2, the logarithm of x in base of 3. We also transpose 15 to that side, it becomes a negative. So that's negative 15 is equal to 0. So as you can see, guys, it's a normal equation that you can choose to solve direct. This one is in your hands. You can choose this one. Remember our equations, guys. Or if you don't want to have confusion, since we can see that we now have log x base 3, which is the common, log x base 3, which is common. So I can just introduce a constant there. Let k be equal to the logarithm of x in base of 3. So if k represents the logarithm of x in base of 3, it means I'm going to have a new equation. Here it's now k to the power of 2. So you're going to have k squared minus 2. The logarithm of x in base of 3 represents what? K. So it's going to be k minus 15 is equal to 0. So as you can see, I have a normal equation that I'm used to, not the log that I'm not used to this log. I'm used to something like this. So you can write it in a way that I want. So from there, we can be able to factorize. Yet just gonna obtain two brackets, equate them to 0. So you can see the coefficient of k squared is a 1. So you're gonna have k and also k here. Consider the factors of negative 15. So you're gonna consider the factors of negative 15. That will add up, or that will give us a negative 2. So factors of negative 15, that will give us a negative 2. That will be negative 5 and 3. If we multiply this, we get negative 15. If we add this, we get a negative 2. So that's we've got negative 5 and positive 3. All right. So from the 0 concept, it means one of the brackets must be equal to 0. So k to that side, minus 5 to that side, it becomes a positive, or k is going to be positive 3. To the other side, it will be a negative 3. So that's we've got two solutions representing k. But remember, this equation, it's not for k. It was x. We are solving for x, not for k. So you're supposed to remember now and go back to the original introduction that we made here. Remember, we introduced to say, let k be equal to the logarithm of x in base of 3. So it means the logarithm of x in base of 3 is equal to k, and our k on the first solution is 5, or the logarithm of x in base of 3, which represents k in this case, is equal to what? Is equal to negative 3. So we are now putting back in place of k, we are now putting back our log x base 3. So that's an equation that we're going to solve for x now. This was for k, but we are supposed to solve for x by introducing back log x in base of 3. So the concept is, how are you going to solve for x? Remember from your logarithms, I talked about this part of converting from a log to an exponential form. The logarithm of a in base of b is equal to c can be written in this way as a is equal to the base b to the exponent of c. So this is what we have. This is our x representing a. So it means this x will be equal to the base to the exponent of the answer. So that is 3 to the exponent of 5, or the same x that we have here is going to be equal to 3 to the exponent of the answer, which is 3 to the exponent of negative 3. All right, this is you and your calculator, guys. X, 3 to the exponent of 5, that will be 243, or 3 to the exponent of negative 3, which is going to be 1 over 27. Here, I'm not going to waste much time. Just use your calculator here. So these were the expected values for x, which will represent x in this case. So it was just a matter of conversion, change of base, our logarithms. Guys, let us know our logarithms. Let us know our logarithms. It's very, very important to understand your laws of logarithms to answer these typical questions. So that was it. Can I say how many marks? It was 5 marks, all right, of which it was, yeah, fine. Simplify, yes, just 2 marks. Simplify. What is it that they want us to do? We had a similar question. I think it was Feb 2022. Yeah, Feb 20, or it was just a similar question like this, whereby they give you the exponent of half, and here they give you all numbers. All right, I said this is a difference of 2 squares. It's a hidden difference of 2 squares. What am I trying to say if I'm saying it's a hidden? It's a difference of 2 squares which is being hidden. I want us to consider these terms, a half and x. x to the exponent of a half, when being squared like this, it gives us x, because this will cancel. Half of 2 is 1, and you're going to have x. And if I write x to the exponent of a half squared like this, minus y to the exponent of a half squared like this, it's a difference of 2 squares, because I'm having a squared and a squared. But a half times a 2, it's 1. A half times a 2 is 1. So meaning to say x minus y, when written in terms of x to the exponent of a half to the exponent of 2, it was a difference of 2 squares. But in simplification, look what we are getting. We are just getting normal x minus y. So meaning to say they are playing around that. They want you to understand the concept of a difference of 2 squares, to say this x that we see on 16x can be written as 16x to the exponent of a half like this to the exponent of 2. Half of 2 is 1, so we've got 16x minus this 9y that we see can be written as 9y to the exponent of a half to the exponent of 2. As we can see, a half times the 2 is 1. So meaning to say we are back to our normal expression of 16x minus 9y. But we want to have it as a difference of 2 squares, all right? And the other part, we are just going to rewrite as it is 4x to the exponent of a half, 3y to the exponent of a half. So like, as you can see, this is a difference of 2 squares. This is a perfect square. So remember, we're just going to find the square root of 16, which is 4. X to the exponent of a half being raised to the exponent of 2. We are just going to take this x to the exponent of a half. Just like if you are given a squared minus b squared, your answer is going to be a minus b into a plus b. You're simply taking the number being raised to the exponent of 2. So this is the one being raised to the exponent of 2. So the same thing here, the square root of a 9, that will be 3, but one bracket is going to subtract. And here we're just going to take this as y to the exponent of a half. Remember, difference of 2 squares, one subtracts, another one is adding. So we are simply having a repetition of these numbers, but on the other bracket, we are going to add 4x to the exponent of a half plus 3y to the exponent of a half. Everything over what? Everything over the denominator that we are given, which is 4x to the exponent of a half plus 3y to the exponent of a half. They are trying. Actually, our department is trying on this question. The repetition, yes, but it's something that you just need to focus. They are no longer giving us those direct difference of 2 squares that, this is a difference of 2 squares. Let me, no. So they need us to revise as much as we can. So as you can see, these two, we will cancel, and we're going to remain on this part with 4x to the exponent of a half minus 3y to the exponent of a half. So that was going to be our answer. Or if you want, you can write in terms of the square root, all right? Remember, to the exponent of a half means the square root of. So it can be the square root, here it can be 4 square root of x minus 3 square root of y, like that. It's one and the same thing, just one and the same simplification. All right, 2 marks for that, as you can see. That's okay. Let's just say 2 marks is enough. But yeah, I don't know what you say or what you think about this question having 2 marks. Let us consider this. Let us talk about this on the comment section, guys. Let me know. What do you say? What do you think about this typical presentation of our questions, so that we can talk about it. Let us just have a discussion there. Let's discuss. All right. On question number 3, it was okay, a word problem. So let us just check and see how we're supposed to have this question on a word problem. That's 3.1. We're given if each side of a square, all right, take note, we're given the side of a square. This is a square that we're talking about here. Okay, 6 marks for that. So we're given the side of a square in this case. Remember, a square, all the sides are the same. We are having the same length for a square. So we are given each side of a square is increased by half of its own length. Okay, what is the side? What is the length of this square? We do not know. The length of this square, we do not know about it. So we can just say, let the length of the square be equal to x, so that we just write it in terms of x. So that is x here, that is x, that is x, that is x. The sides are the same. So they are saying each side is being increased by half of its own length. So you're going to have another square in this case. All right, because if each side is increased, it means we are going to form a square. We are not going to form a rectangle. We are going to just form a square, but this one is going to be a bigger square in this case than the one that we had, because we have increased by half. So this is for the original square, this one, which is x. Then for the extended, or for the larger square, in this case, we're going to have it increased by x, by half of the length. So the length is going to be half of this. All right, so it's going to be x plus half of this length, which is half of the original length, because it's increased. To increase, you add, that is to increase. So it means that it is going to be 1x plus 2x. 1 plus 2, 1 plus a half in this case is half x plus a half x, a 1 in this case. So that's simply 1 plus a half. That's 1 plus a 1 over 2, like this, which is going to give us 3 over 2. So it means this is being extended to 3 over 2x. So each length is going to be 3 over 2. So here we're going to have 3 over 2x. Here we're going to have 3 over 2x. Here we're going to have 3 over 2x. Remember, this is a rectangle, or a square. All the sides are equal. So we have got the smaller one, and we also have the bigger one from this, because it is being extended. All right. So the question here is not about the sketch that we are having. No, they are saying it forms a larger square, which is this one that we have formed. From there, the difference between the perimeter of the larger square and the perimeter of the smaller square, remember, because we are now comparing, we've got two squares. So this becomes the larger, this becomes the smaller square in this case. So they are saying there's a difference. So definitely the difference is the bigger perimeter minus the smaller perimeter. We can't subtract the bigger one from the smaller one. It will be the smaller one from the bigger one. So in terms of perimeter, we know that the perimeter of a square, in this case, the perimeter of a square is 4 times s, which is 4 times one of the side, 4 times the side, or we can write this as 4L. Talking about the length, we can write our perimeter as equal to 4L, which is the length, or 4 times s, which is the side, side plus side plus side plus side. So they are saying the perimeter in this case of the larger one and that of the smaller one, the difference there is 12 meters. Determine the length of each square, meaning to say they want us to determine the length of the smaller square and also the length of the larger square. But given that their perimeter, they've got a difference of 6 meters. So it means the perimeter in this case of the larger square, the perimeter in this case of the larger square minus the perimeter in this case of the smaller square must be equal to 12 meters. We are given that it is equal to 12 meters. So we are going to have the difference. So like I said, perimeter simply means 4 times the length or 4 times the side, one of the given sides. So from the larger one, it is going to be 4 times the length, which is 4 times 3 over 2x. So this will be 4 times 3 over 2x minus the perimeter of the smaller one, which is 4 times the side, which is x. This must give us a 12. So as you can see, it's an equation that we are actually formulating. We have actually formulated an equation that we are supposed to solve for x. This is an equation that we have. So you can solve for x. Just multiply these values from a calculator. This would be 6x. All right, 4 times 3 over 2 is going to be 6 there. Let us see from our calculator. If we multiply 4 times 3 over 2 in this case, all right? So that will be a positive 6. So we're going to have 6x minus 4x, which is equal to 12. So in order for us to solve for x, we are simply going to subtract these two. As you can see, these are like terms. So 6 minus 4, that is going to be 2x, is equal to 12. So in order to have the value of x, we can divide by 2 both sides. That will give us the value of x, which will be a 6. So x in this case is going to be a 6. X representing what? The length of the smaller square. If we take note here, we talked about the smaller square. Its length is equal to x. So meaning to say, by calculating this x, we have calculated the length of the smaller square. So in this case, for the smaller square, we are going to have our length as 6 meters, which is the value of x. Remember, our length here is given in terms of meters. From these units, we are given 12 meters. And for the larger square, our length is given as 3 over 2x. So it's going to be 3 over 2 times x. That will be for the larger square in this case. So for the larger square, our length is going to be 3 over 2x as we are given here. The side is 3 over 2x. So meaning to say, if our length is equal to 3 over 2x, we're just going to multiply 3 over 2 times x, which is 6. All right, so that will be a 9 in this case. If we simplify properly, or from our calculator here, we can just save it on our calculator. Remember, that's 3 over 2 times 6. So it's going to be 3 over 2 like this. 3 over 2, sorry, that's 3 over 2. Multiply to 6 like this, that would be a positive 9. So meaning to say we can have this side as a 9. So that is the length of the larger square in this case. So that will be 9 meters. All right. So we're talking about the length in this case, which is the side of a square. 6 marks for that. Okay, these are word problems. So a word problem, you formulate it to the statement that you are given. The word problem that you're answering now is different from another word problem that you be given. You use the information that you are given there to formulate a statement that you're going to solve. Sometimes you can form simultaneous equations. Sometimes you can form a quadratic equation. Sometimes you can just form a linear equation like this. It differs with the equation that you are given in that question. All right, so that is what we had in this case. Let us check 3.2, make x the subject of the formula, whereby we are given that a is equal to a plus b to the exponent of 2x. So this is a capital letter. Then we've got a small letter, and b a small letter. So we're asked to make x the subject. So as you can see, x is on the exponent. So we're going to introduce the logarithm. So it's either you introduce it as a line like this, which represents a log, or you can represent it as the logarithm like this. It's just one and the same thing. All right. So as you choose which part that you want to apply. The moment you use our logarithms, therefore here we're going to drop our exponent. Remember, an exponent on a logarithm multiplies the logarithm. So that is going to be the logarithm of a is equal to 2x into the logarithm of a plus b. So what we want here to make the subject is x. What is affecting this x? It's 2 and the log of a plus b, which is multiplying. So we are simply going to divide by it both sides so that we remain with x. We're going to divide by 2, the logarithm of a plus b here. Also divide this side by 2, the logarithm of a plus b, like this. All right, so that is it. This will cancel. This will cancel. We remain with x in this case. So x was going to be equal to the logarithm of a over 2 into the logarithm of a plus b, like this. All right, so that was going to be the simplification for our x in this case, which was 3 marks for that, okay, which is sufficiently fine for the 3 marks that we are having there. It's actually something that is fine. All right, so that was the end part of this section. All right, let us check the other part of our section here. So you can see that was the end part. 3.3, a simultaneous equation. So this one is a quadratic type of a simultaneous equation. So I'm just gonna write it aside so that we see what was best in this case to solve this equation. So our equation that was 3.3. Let us just have it on top here. We are given to solve the following system of equations simultaneously, which is 3x minus 2y minus 6 is equal to 0. That's the first one. And we are given x squared over 4. In this case, that was minus y minus 1 is equal to a 0 in this case, like this. All right, I just hope I took this exactly the way that it was. So in this case, we are being asked to solve simultaneously, that is to find the value of x and to find the value of y at the same time. We've got 2 equations that we are supposed to put into consideration, which is our first equation and also our second equation. So you're going to choose, because this one is a quadratic simultaneous equation. We've got the highest exponent here being a 2. So on your choosing part, it's wiser enough that you choose from a linear equation. This one is a linear equation. As you can see, the highest exponent that we have there is what? It's a 1. And it's also wiser for you to choose the part that is not being raised to the power of 2, which is x. So on choosing to make one of these letters to be the subject, it's wise for you to choose the part that is not being squared here, because if you choose x, you are going to square that part. But if you choose y, you're just going to substitute y as it is not being squared. So that's what I'm trying to explain. So let us choose from equation 1. I'm just going to choose y to be the subject, since this term is not being squared on the other side. But if you want, you can choose x, but you have to square it. It's up to you on the choice of making the subject. All right. So I can just transpose negative 2y to the other side so that it can be positive. That will be 3x minus 6 is equal to the positive of 2y in this case. So to find y, we can divide by 2 each and every term, or we can just have this every term over 2. It's up to you. Or you are going to have each and every term over 2 like this. All right. So it's just one and the same thing. So you're going to divide here, meaning to say y is equal to 3x over 2 minus 6 over 2, which is same as 3. So that's y is equal to 3x over 2 minus 3, which is one and the same thing. As having this, you could have just written this everything under the same denominator of 2, which is y was going to be equal to 3x minus 6, everything over 2 like this. It's just one and the same thing, right? Or you can divide every term by 2. It's just one and the same thing. So that's, we have made this from the first equation. So I'm going to substitute into the second equation in this case. So we are going to substitute. This is now equation 3. So let us just say equation 3, substitute equation 3 into equation 2. So that's the equation. Let me just write in short equation 2 like this. So our equation 3, that is y is the subject in this equation. So you're going to just substitute as it is in place of y. So you're going to have x squared over 4 minus y in this case, which is 3x. So as you can see, you've got a fraction. So it's going to be wise to substitute that as it was. Oh, let us just see. Let us just use this one, which is one and the same. Then here we've got minus 1 is equal to 0 like that. All right, let us expand and see. As you can see, this is now a normal quadratic equation. So you can just expand by negative inside. So it's going to be x squared over 4. Negative here is going to be negative 3x over 2. Negative, negative, which is going to be positive 3. That is the effect of the bracket. It's only going to affect the bracket. This negative is just only going to affect our bracket. The negative 1 is out of the bracket, so it's going to remain as it is. All right, so if we are to collect our like terms, we're going to see that we've got 3 and 1, which we are going to subtract. 3 minus 1, which is 2. So we are going to have x squared over 4 minus 3x over 2 plus 3 minus 1, which is 2 in this case, is equal to 0. So we can formulate a normal quadratic equation by having the coefficient of x squared as a 1. So in this case, to have this, we're going to multiply each and every term by 4. Or we can multiply by the LCM of the denominators, which is 4. So you're going to multiply here by 4 this term. You also multiply this term by 4. You also multiply this term by 4. You also multiply this term by 4, each and every term. So 4 and 4 will cancel. You are going to remain with x squared minus, let's divide here 2 into 4. That is going to be a 2. Then you multiply, or just use your calculator at once, negative 3 over 2 times 4, like this, all right? That will give you a negative 6, but there is x here. Then 2 by 4, which is 8, must be equal to 0 times 4, which is a 0 in this case. Remember, this is the same as over 1. So as you can see, this is a normal quadratic equation that we can solve for x, taking into consideration that here the coefficient of x squared is 1. So you're just going to have 2 brackets to consider. equal to 0 in this case by factorization. So by factorization, we're going to consider this as, all right, the factors of 8 that will give us -6. So we need factors of 8, but these factors of 8 should give us -6. So we're going to consider -4 and -2. -4 by -2, they will give us a +8 if we multiply. If we add -4 plus -2, we are going to get a -6 if we add like this. Okay, let me just explain this on a calculator because some of us have been asking this question. Simply saying, if we multiply -4 by -2 like this, we are going to obtain a +8, this one. But if we add these two terms like this, if we remove this and add, we are going to obtain -6, which is this one. That is the concept. If you add those terms, they must give you the middle term, but factors of 8, that is the concept. So you're going to have -4 and -2. So one bracket must be equal to 0, or here there's an x there. So it means x minus 4 must be equal to 0. So x will be a +4. Or if this bracket is equal to 0, it means x is going to be a +2 on the other side. So these are the values of x. 4 or negative, or 4 or +2. So these values, to obtain the values of y, we're just going to substitute in our equation 3 because it's easier to substitute. Yes, you can substitute in equation 1 or equation 2, it's fine, but it's easier here because already y is the subject here. We have got y being equal to 3 x over 2 minus 3. So we're just going to substitute when x is 4, meaning to say y is going to be 3 into 4 over 2 minus 3. So that is going to give us what at the end. So let us just check if we to simplify this as a fraction, that's 3 times 4, everything over 2 like this, then you're going to subtract 3. That's a +3. If x is a +2, so that will be a +2 here. All right, if x is a +2, meaning to say y is going to be equal to 0. All right, so on the other hand, y is going to be equal to 0 if x is being a +2. So these are the possible values that we're going to have at the end. So meaning to say, we are simply saying when x is equal to 4 in this case, y is equal to 3. And when x is equal to 2 in this case, y is going to be equal to 0. That is what you're simply saying from this concept. So this is solving part of the simultaneous equations. That's how you can solve. Okay, as you can see, let us check. We just have to make the subject from one of the equations, which is choose from a linear, and choose also a part that you do not square at the end, depending with the type of equation that you are given. It depends, but this one, it was wiser for us to do it this way. I'm not saying this is the only way to answer this question. No, there are so many ways. Question number 4, we are given a condition that fig 1 shows quadrilateral A, B, C, D with these points, and we are given that AD is parallel to BC. All right, A to D, this side is parallel to BC. These two, they are parallel to each other. All right, then theta is the angle between the line segment BC and the x-axis, this line BC and the x-axis. So it gives us a special name when the angle is taken between the line and the positive x-axis. That angle becomes the angle of inclination in this case, which you can obtain from arctan of the gradient. So that is it. All right, let's see our information. Determine the gradient of AD. All right, that was the first question, the gradient of the line AD, 2 marks. All right, where do we have A and D? As you can see, this is our A and D. So let us just have our gradient here. So this is question 4.11. So the gradient of AD simply from the change in Y over the change in X. That's Y2 minus Y1 over X2 minus X1. You're gonna substitute AD. Maybe this is your X1, Y1, and D, that's your X2, Y2. So you're gonna have Y2 minus Y1. That's the Y value minus the Y value here, which is 9 minus 3 over the X value here, which is 5 minus the X value there, which is -9. So that's it. can just use our calculator to simplify this, or you can just do it direct. All right, let us see. 9 minus 3. So that's 9 minus 3 over 5 minus 9. I'm going to use this one for a negative 9 like this. So that is going to be a 3 over 7. So we're going to obtain a gradient there of 3 over 7. All right, so this one is going to be 3 over 7. So we have got the gradient of the line AD. Then the length of the line segment AD and the simplest set form. So they need us to answer this in set form, the length of AD. So from the distance formula, we can obtain the length of AD. Remember, this is our A to D here. So we can just have, let us just answer it also aside here, 4.12. So the distance of AD from our distance formula, simply from our formula sheet, we are given this as x2 minus x1 squared plus y2 minus y1 squared. So as you can see, we already have these values, x2 this time, that is 5, minus x1, which is a negative 9. So it's going to be the square root of 5 minus 9 like this, which is a plus. All right, plus the y value 2, the y value here, which is 9, minus the y value here, which is 3. So that's it. We're gonna simplify this in the simplest set form. The advantage part that we are using a calculator, so everything is gonna be in the simplest form. So it's the square root of 5 minus 9 like this. Then you're gonna square this plus 9 minus 3 in another bracket, 9 minus 3 squared, just like that. That will be 2 square root of 58. This is the simplest set that you're gonna have. But if you're to simplify stage by stage, this is what you're gonna have. If you're to simplify this by stage, you're gonna have, let's remove the square root. You're going to have 5 minus 9 squared like this. All right, which is going to be 196. So you're gonna have the square root of 196 plus, okay, there's a square here. All right, that's y squared, there's a square there. All right, we simplify 9 minus 3 squared. That's 9 minus 3 squared like this, which is going to be 36. All right, so add everything together. That will be 196 plus 36 in this case, which is 232. This one you are simplifying stage by stage, all right? Then from there, you write the simplest answer in set form like this. The square root of the answer, which is 2 square root of 58. So that's 2 square root of 58 units in this case. So this is the length that you're gonna have for AD, which is 2 square root of 58. All right, 2 marks for that, which is fine. 4.13, determine the equation of the line BC, all right, in the form y is equal to mx plus c, the line BC. If you had to check here, we had a lot of ways that you're going to consider in order for us to have the equation of the line BC. We have got all the points. We've got the point at B and also the point at C. So you can consider finding of the gradient here of what? Of BC. But in this case, are we going to consider that? No, because we are told that these two lines, they are parallel, AD and BC. So I'm just going to take it from what? From AD, because these two lines, they are parallel, all right? So since two lines that are parallel, they've got the same gradient. So it means in order for us to obtain the equation of line BC, we are going to take the gradient concept. Since AD is parallel to BC in this case, so it means the gradient of line AD will be equal to the gradient of BC, which is 3 over 7 in this case, right? So that's it. We can have our equation. And also the format here we're given in the form of y is equal to mx plus c, which is the gradient intercept form. So that's m is the gradient. So we're just going to substitute here, going to have y is equal to mx plus c. That's y is equal to m, which is the gradient. We said is the same. So it's 3 over 7x. C being the y-intercept. So we can check if we've got the y-intercept. We do not have the y-intercept here. The line passes here, but we do not have this point. So we're just going to write it as a c. If we had a value there at the y-intercept, we're going to take that value and substitute there. But this time we have to calculate that value. From where? we are going to either substitute the point B or the point C, because we are talking about the equation of BC. You're going to substitute any of these points, either point B or the point C. So in this case, I'm just going to take this one, which has got positive values, point C, which is 7, 4. All right, so I'm just going to take the point C, which is given as 7, 4 in this case. All right, meaning to say I've got the value of X and also the value of Y there. So I'm going to substitute the value of Y being 4. So 4 is equal to 3 over 7 times X, the value of X being a 7 plus C like this. So that means we can simplify from our calculator. This is going to give us a 3. Then we transpose that 3 to the other side. We're going to have 4 minus 3 is equal to C. So that means 4 minus 3 will give us a 1 in this case. So that's therefore our equation can be written as, remember I said our equation must be written in the form of Y is equal to mx plus C. So therefore our equation is going to be Y is equal to mx, which is 3 over 7x plus C, which is our C in this case, it's a positive 1. So you're going to have a positive 1. So meaning to say this graph that we see, it passes through the y-axis at 1. This point here is at 1. The C there that we see represents the y-intercept. So if we're given that value, we're simply going to substitute that value as it is. But here we are not given. Let us consider another part and see, which is question 4.14. Now they want us to calculate the size of theta, which is the angle of what? Inclination. Remember I talked about this, that theta simply represents the angle of what? Inclination. So let us check where is theta. It's between which line? Theta is between the line BC. So meaning to say we can obtain that theta from the line BC in this case. So it means that will be 4.14. It means from our angle, theta, it is going to be arctan of the gradient in this case, the gradient of light, the gradient of line BC in this case. And we have this gradient of BC. Remember, I said the gradient of BC and the gradient of AB is the same, which is 3 over 7. So that will be arctan 3 over 7 in this case. So theta is going to be given as arctan 3 over 7. So that's it. We are going to have our theta. From there, from our calculator here, if we are to simplify properly, arctan, that's shift tan in this case, 3 over 7. All right, so that's it. We are going to have 23,195, which is 199 there. So it's 23,19. 23,199 degrees. All right, that is to 3 decimal places. If you had to write to 3 decimal places, that will be our angle theta. Or someone can just write as 23,2. It's that one. It's up to you. It's a choice, but you can just have it like that. All right, so let us check the other part that can that we are given. The equation of the line perpendicular to the line AD and passes through the point A, -9, 3, right, in the form. All right, so the form here is of y is equal to mx plus the gradient intercept, just like the previous part. So this line is perpendicular to AD and passes through point what? Point A. All right, let's check our statement again from the diagram. They are saying we are supposed to determine the equation of the line. All right, this is what we are given. Let us check if we're going to have space to see properly here. All right, they want us to find the equation of the line perpendicular to AD. This is our AD. All right, let us write it aside. All right, this is 4.15. The line is supposed to be perpendicular to AD, the line that we are supposed to calculate. We do not know this line. The line that we are going to talk about, it must be perpendicular to AD. So what does it mean? It means the gradient of the line that we're going to have times the gradient of the line AD should give us -1. Remember, perpendicular lines, the product of their gradients should give us a -1. So meaning to say we can have the equation of this line because we are told, or we have calculated actually the gradient of AD, we got 3 over 7. So it's going to be the gradient of the line that we want to calculate its gradient times that of d, which is 3/7, should give us -1. So the gradient of the line that we are supposed to calculate its equation is going to be what? Just divide here by 3/7, this side by 3/7 to give us what? To give us the value of the gradient, which is m. So on our calculator, it's -1 divided by 3/7. All right. So that is something like this: -1 divided to 3/7. Right? There are too many fractions there. That will be -7/3. So meaning to say our gradient m is going to be -7/3. And we are told on this information, since we have the gradient, we can calculate the equation because we are told that this line is going to pass through the point A, which is -9, 3. So we are given where this line is going to pass through. It's going to pass through the point A given as -9, 3. So we are simply going to find the equation because we have the point and also we have the gradient, and we are given that we are supposed to write in the form of y is equal to mx plus c. So simply you're going to substitute y is equal to m, the gradient, -7/3x plus c. So we are simply going to substitute our values. This is our x, this is our y here. So y being 3, x being -9. So that's -7/3 into x being -9 plus c. Okay, so let's see from our calculator here, guys. -7/3, -7/3 times, all right, sorry for that, that's a times -9. That will be +21. So you're gonna have 3 is equal to +21 plus c. Transpose this to the other side, it becomes a negative. So that will give us the value of c, which is 3 minus 21. So 3 minus that answer is going to be -18. All right, that's a -18. So meaning to say, we can rewrite our equation as, therefore, the equation now is going to be given as y is equal to mx, which is -7/3x plus c, so it's plus, and a minus, which is going to give us a -18 in this case. All right, so that's how you simplify the equation of a line, but we are told that it's perpendicular. If they say it's parallel to, it means we are going to take the same gradient, but for perpendicular lines, the product of their gradients should give us what? -1. But if the lines are parallel, like the last part that we talked about, parallel lines in this case, if the two lines are considered to be parallel, they have equal gradients. We're going to equate the gradient. That is what you simply need to understand. Otherwise, the rest here is just a repetition on finding the equation. After knowing the gradient and the point, the equation finding format here is the same. Y is equal to mx plus c. You substitute your gradient and the other point to find c. All right, then on question number 4.2, this is 4.2, they are saying show that line AC and BD bisect each other. All right, show that they bisect each other, AC and what? And BD. Let us have our statement again. All right, this is what we have. Do we have the points here? We've got AC. Okay, this is a straightforward question. Let us remove this, guys. This is a straightforward question. This information is not even necessary. Let me remove this whole part here so that we have our question properly. All right, remember our question is saying we are supposed to show that, or we are supposed to prove that line AC, that was line AC and BD bisects each other, in this case. All right, so what does it mean? It simply means if we have got line AC and we've got line BD like this, we are going to have the same midpoint if they bisect each other. So we are simply going to calculate the midpoint of the line AC. So we are simply saying the midpoint of line AC must be equal to the midpoint of the line BD in this case, if these two lines are having the same midpoint. So meaning to say, the midpoint of AC. Remember, the midpoint is simply taken from the x values. You're going to add the x values. That's x1 plus x2 over 2. Here you add the y values, y1 plus y2 over 2, which is the same concept that you're going to do on this part. You add your x values, x1 and x2 over 2. Then you also add your y values, which is y1 plus y2 over 2, like this. So you must have the same answer. For AC, we are taking this our point A and our point C. So you're going to just consider x here, which is 9, -9, and x here, which is 7. So that's -9 plus 7 over 2. Then the y values, you've got 3 and you have got a 4. So it's going to be 3 plus 4 over 2. So that's our midpoint. It must be equal to that of BD. So BD, we are considering this line whereby the x value is -7. Here it's +5. So that's -7 plus 5 over 2. That's the x value. Then the y value is -2 and 9. -2 plus 9 over 2, like this. All right. So let's see. Here we are going to obtain from our calculator, I think, but this is direct. It's going to be -2 over 2, which is -1. Is that so? -9. Just use your calculator if it is possible. Over 2, like this. That will be a -1. So we've got -1. Here, we're going to add, that will be 7 over 2. Okay, which is equal to here negative, this is -2 over 2, which is -1. Also here, -2 plus 9, that's 7 over 2. So as you can see, the answers that we are obtaining at the end are the same. The one that we calculated from AC and the one that we calculated from BD. So it means these two lines, they do bisect the same point, since the midpoint of these two lines are the same. All right, the two midpoints are the same, so it means the two lines, they bisect each other. So therefore, line AC bisects each other with what? With line BD in this case, with line BD, since they have the same, in this case, midpoint. In this case, they've got the same midpoint. So we are considering the midpoint in this case. So that is the condition. So it means this shape can actually be considered to be a parallelogram, if you consider it that way, or you can consider the depending with the shape that you're going to have in terms of the length and also the angles. We proved something, it was perpendicular. Let's check which one was perpendicular to which one. The line segment of this, I want to just, because it can be a rectangle or it can be okay, the line perpendicular to AD and passes through A. All right, is it possible for us to have a line perpendicular to AD and passes? So it means if this is perpendicular, that will be a rectangle in this case. But if it is not, then it is just going to be a parallelogram. But we're not asked about that, all right? We are not asked about that. That was, 5 marks. Okay, so that is the proof part. So you've got 5 marks for this part, guys, all right? So you just needed to show them the midpoints in this case, all right? That is what you are asked there. Okay, so let us check the other part. Question number 5, draw the graph of the following, showing all the intercepts on the axis in this case. All right, so this graph here, we are given, all right, let me just write it aside. We're given the graph of 5.1, that's x squared over 256 plus y squared over 121, which is equal to 1. So this is not a circle, guys. How many marks are these? 3 marks. This is not a circle. This is an ellipse. A circle, we must have the same numbers here. If this is 256, this must be also 256. If these numbers are different, it means you're going to have an ellipse there. But do not worry about that. Just calculate your x values and your y values. So you're going to just need your x intercepts in this case, where y is equal to 0. So if y is equal to 0, guys, you can see that this one is going to give us a 0. So it means we are going to be left with x squared over 256, which is equal to 1 over 1. This is 1, which is same as 1 over 1. So you can cross multiply. X squared is equal to 256 times 1, which is 256. Determine the values of x by introducing the square root. You're going to have the square root of 256, which is going to be plus or minus 16. That is the same thing for the y-intercept. If you're talking about the y-intercept, x must be equal to 0. So meaning to say this will be equal to 0. Now we are left with y squared over 121. So you're going to have y squared over 121 is equal to 1. So this is cross multiply so that we can have the y values. Y squared is equal to 121. So we're going to have the value of y here by introducing the square root both sides. So that's y is equal to plus or minus 11. So as you can see, the y values here, they are different. The y value, the y value and the x values are different. So it can't be a circle, because a circle, it is supposed to have the same radius from the same point like this. If this is 4, this must be 4, this is negative 4, negative 4. But if we check this, for x values and y values, they are different. We are having the x values bigger than the y values. So on your graph that you're going to have, you're going to draw a proper graph, but you must have your x values at negative 16 and at positive 16. All right, plus or minus. Then the y values at positive 11, let's just say here, and maybe somewhere here. So it's going to be an ellipse if you join. It's not going to be a circle. This one is not a circle, guys. It's an ellipse. All right, so just check also the graph there. Gonna see something of this nature. So that was going to be the sketch, something like that, right? So you're supposed to draw properly, but here I'm just giving you a sketch of what this was supposed to look like. That is going to be x squared over 256 plus y squared over 121 is equal to 1. Okay, so that was our graph there. 5.2, determine dy dx of the function by using the rules of differentiation. The final answer must be positive exponents and in set form where applicable. All right, remember I talked about derivatives a lot, guys. All right, no problem. Let us just consider our question we are given. In this case, that is 5.2, y is equal to 1 over x plus 2 square root of x minus 1 over the square root of x. All right, by using the derivatives, what is important is to have a format that you can be able to differentiate. The format of y is equal to ax to the exponent of n. Since we know that the derivative there of y with respect to x, you're going to drop the exponent. It will be an x to the exponent of n minus 1. So you just need this format, all right? So here we're just gonna rewrite our expression. 1 over x from our exponents is x to the exponent of negative 1, all right? Plus the square root of x means to the exponent of a half, okay? So it's the same thing here. We're gonna have 1 over the square root of x, which is 1 over x to the exponent of a half. But the moment we take it on top, just like 1 over x, the moment we take it here, it's going to be a positive. So it's going to be minus x to the exponent of a negative half in this case. All right. So you're going to find the derivative of y with respect to x of each term. So you're going to drop this exponent here. There's a 1. So you multiply this, you subtract a 1. So if we multiply this, we're going to have a negative 1, which is just negative 1 or negative x. Then we subtract negative 1, that will be a negative 2. All right, we do the same thing. We're going to multiply this half times 2, which is going to be a positive 1. So that's a positive 1, which is just x in this case. All right, just write x there. Then we subtract a 1 on top. All right, we're subtracting 1. So a half minus 1 is going to give us a minus half. So that's a minus half there. We do the same thing here. Here's a negative 1. So it's a half, a negative half multiplied by this. If we multiply negative half times negative 1, it will be a positive half in this case. We're going to have a positive half. X to the exponent, you subtract 1 on the exponent. So negative half, negative 1, it will be negative 3 over 2 in this case. So that was the idea of our simplification. Then from there, we can simplify as far as we can. Remember, we talked about the issue of removing the negative before. Now we have the negative on the answer, so we're going to take it back to the 1 over x that way. So it's going to be minus 1 over x squared. We do the same thing here. There's a negative, so it's going to be plus 1 over x to the exponent of a half. We do the same thing. There's a negative. We're going to take it down. So it's going to be plus 1 over, already there's a 2 in our denominator. So it's going to be 2x to the exponent of 3 over 2. But they also are referred to the issue of simplification here to say, whatever that you're going to have, you must have it in terms of positive exponents here. If you check in terms of positive exponents and in said form where applicable. So it means we're gonna, here we now have all these, they are positive exponents, but also there are terms that you can write in said form, that is in terms of the square roots. That is what they are saying there. So it's going to be minus 1 over x squared plus, remember, to the exponent of a half means the square root of. So it's going to be 1 over the square root of x, that is in said form now. All right, from our laws of exponents, a to the exponent, let's just say x to the exponent of a over b like this means the bth root of x to the exponent of a. So it simply means here, this means the square root. We've got x to the exponent of 3 over 2. So the 2, just like the b, is going to be inside the square root, then the x here to the exponent of 3. But remember, 2 here inside the square root, we do not write it. So we are going to write this 2 that is multiplying. So we are going to have this as plus, all right, we're going to have this as plus 1 over the 2 that is multiplying this answer here that is same as the square root of x to the exponent of 3. So you're going to have this as 1 over 2, the square root of x to the exponent of 3. So these are the steps that you were supposed to consider or to take into consideration when simplifying this type of equation. Then 5.3, determine, given this function, we are asked to determine the coordinates of the turning point, all right? Coordinates of the turning point of f of x, all right? So remember, for the coordinates of the turning point, it follows that the first derivative must be equal to 0. So we are given our f of x being equal to x to the exponent of 3 minus 6x. And at any turning point, the first derivative with respect to x must be equal to 0. So meaning to say, we are simply going to need the first derivative of this expression, which is we are going to differentiate. So if we differentiate, we're going to multiply 3 times 1, which is 3. We subtract 1 here, so that will be 3x squared. Minus 6x, it's a linear expression, so it's just going to give us a negative 6. The question is not asking you to differentiate, no. The question is asking you to differentiate and also to find the turning points. You're asked about the turning points in this case. So you're saying the first derivative of this must be equal to 0. So meaning to say we are simply going to take this part, which is our first derivative, and equate it to 0. So that will be 3x squared is equal to positive 6. To find x, we're just going to divide by 3. X squared is equal to 2. So as you can see, we are supposed to obtain 2 possible values from the square root of x. The square root of 2, in this case, is going to be plus or minus 2. That will be 2 values that we are obtaining. So we can have our x being the square root of 2, or we can have our x being the negative square root of 2. So these are turning points, whereby if we are talking about turning points, we must have the value of x and the corresponding value of y in this case. So meaning to say, in order for us to have the value of y, we're going to substitute into the normal equation. Remember, y is equal to f of x. So it means y is equal to the original equation of x cubed minus 6x. So you can even write this as a decimal. So you're going to take the first condition of our first turning point to say if x is being the square root of 2, or you can write it as a decimal. Let me just also bring the calculator so that we see what is the square root of 2 there. So if we check, the square root of 2 in this case is the same as 1,4. 1/4. So you can write it as a decimal if you want, or you can just substitute as it is. In place of x here, we are going to substitute the square root of 2. So it's going to be the square root of 2 like this to the exponent of 3 minus 6x minus 6 into the square root of 2 again like this. All right, so that is going to give us minus 4 square root of 2. So it means if x is the square root of 2, y is going to be minus 4 square root of 2. That's it. Or as a decimal, it is going to be minus 5 comma. If you obtain this answer, we are in the same direction. All right, and the second turning point, it's at a condition where x is negative square root of 2. So if we've got negative square root of 2 in this case, then we're going to need the y value. So I'm just going to substitute here, put a negative. Also here, put a negative like this. So it is going to be positive 4 square root of 2. So this is going to be positive 4 square root of 2 like that. All right. So that is the idea, or as a decimal is going to be what? Positive 5,65 and so on. So it's that one is your choice. Which one do you want to express your answer as? Is it as a decimal, or you want to just have your answer in this format as the square roots in this case? All right, let us just see. Here it was 5,6. 5,65, it's going to be a 7. And this was negative 1,414. All right, which is positive 1,414 here, negative 5,657. All right, so let us just see. Okay, it's fine. So that was the first part that you're going to have here. And the other part now, they are saying sketch the graph of f of x showing all the points of intercept and the axis of the turning points. All right, so already we calculated the turning point. This is a cubic function that we are having, and we are supposed to have a sketch of this function that we are having here. So what would be the idea now for this function? All right, in order for us to consider a sketch, it's a cubic function, as you can see, and here the coefficient of x cubed, it's a positive. So we're going to expect our function to be of that nature. But here, as you can see from our solution, I'm just saying about the shape. But in terms of the solutions here, because in order for us to have this sketch, we are supposed to have the x-intercept and the y-intercept in this case. All right. So for the y-intercept, we're going to consider a condition where x is equal to 0. If we substitute x here in place of y, because y is equal to x cubed minus 6x, this will be as 0 in this case. And if we consider our x-intercepts in this case, where y is equal to 0, it means this whole function here of our f of x or y must be equal to 0. X squared, x cubed, sorry, minus 6x must be equal to 0 like that. So if we factor out x, we're going to have x into x cubed divided by x, which is x squared minus 6 is equal to 0 in this case. So our solution is going to be x, which must be equal to 0, or the bracket of x minus 6, which must be equal to 0. So x there, x squared will be equal to a positive 6. So in order for you to obtain x, you're going to introduce the square root. So therefore, our x was going to be equal to 0, or remember, the square root of any number there is going to be a plus or minus. We are going to have one solution of x being a negative square root of 6, another solution of x being a positive square root of 6. There are two solutions that we're going to consider there, of which the square root of 6, let us just save it as a decimal just for comparison, because remember, last time we had the square root of 2. Now we want the square root of 6 just for comparison's sake. The square root of 6 is 2,449. So something like negative 2,449. All right, so that's 449 or 2,449 like that. All right, so that is just for comparison's sake when we are comparing our values, because we also have a square root there. So this is enough, because we've got the turning points, and also I talked about the issue of the sketch. So it's going to be going to the positive values because we are having the coefficient here as a positive. So on our sketch, we are going to have this, the most important part of our sketch. All right, let us consider our x values. In this case, our x-intercepts, that's at 0 here. Another one at negative square root of 6, meaning negative 2,46, somewhere there. So you can just maybe somewhere here, negative square root of 6. Here, that's the positive square root of 6, which is 2,499. So our graph is supposed to be something like this, going up, because there we have got x-intercept, and look at the shape that we considered here. And the y-intercept is at x is equal, which is at 0 in this case. So meaning say this graph is going to pass at 0. Gonna go this side, it goes down, then up. So meaning to say we are just gonna have something of this nature. Let us just say for a sketch, something of this nature. It goes up to the turning point, then from that turning point, so it's just gonna go up. Let us just save this a little bit. So it's just gonna go up to the turning point, then to the y-intercept. Remember, our y-intercept is supposed to be at 0. Then to another turning point, which we do not know, somewhere there down, then it goes up. All right, we actually know this turning point, but I'm just saying for sketching part, you can just consider this. Then you put your values at the end. All right, so there we understand we must have a turning point here, and we also must have a turning point. So which turning point are we going to consider? Because we talked about the turning points here. There's the one that carries a positive 1,414, or the square root of 2 into minus 4 square root. So this is the one that goes to the positive. So you've got the square root. Remember, it was the square root of 2 into minus 4 square root of 2. And we've got another turning point at negative square root of 2 at the negative side. Because we're at the negative, we're going to consider this as negative square root of 2 into 4 square root of 2, like this. All right, so that is going to be our sketch. So this is enough, and we can just have our name of the function. Remember, f of x is x cubed minus 6x. So you can just have this as f, or you can just write f of x is equal to x cubed minus 6x, like that, which is one and the same thing. So that was the idea of the sketch. You needed the x-intercepts and also the y-intercept. From these intercepts, you mark them on your graph. Okay, you mark your intercepts, like that. Then you can be able to sketch the graph in this case. That was 4 marks for that. All right, question 6, it was a trigonometry whereby we are given to prove use trigonometric identities to prove that. All right, there we've got a complicated scenario, which is equal to 1 plus sine x over 1 minus sine x. All right, so let us see what we have. Remember, on the proving part, you're going to choose the side that you want to work from. So let's say, okay, let me just write it down so that we choose and see which part are we going to work. Remember, we are given the 6.1. We are given the trig of tan of x. So this is tan of x plus 1 over the cosine of x. Everything to the exponent of 2 must be equal to 1 plus the sine of x over 1 minus the sine of x. So I'm just going to choose the complicated part here, which is the left-hand side. All right, so let's see. From our left-hand side, we are given that we've got the tan of x plus 1 over the cosine of x being raised to the exponent of 2. All right, how are we going to prove up to this part? All right, remember, we've got tan. Let us just change our tan to a cos, because we understand that tan represents sine over cos in this case. So it's just going to change. This will be a sine of x over a cosine of x plus 1 over cos x. All right, so you have to add this part, sorry. So you're going to add 1 over the cosine of x, everything to the exponent of 2, which is fine. And as you can see, we can have this scenario here of 1 plus sine x, 1 plus sine x here. So what's going to simply happen is that the denominators are the same. So you're simply going to add our numerators. Remember, I explained a over b plus c over b simply gives us a plus c over b, because the denominators here are the same. So we are just going to combine the numerators here. Sine x plus 1, which is same as 1 plus sine x. So we've got sine x plus 1, everything over cos and cos, which is the same. So it's just going to remain as a cos. Just like if this is b, this is b, this is b. It's not going to be b squared or what. All right. So this is just a cos x. But being raised to the exponent of 2 like this. So we've got two brackets that gonna be considered. All right, anyways, let us see, because there's a square here, there's a square that we have. So it means let us just have our numerator, which is sine x plus 1 squared, all right, or 1 plus sine x, all right. So you're gonna have sine x plus 1 being squared like this over the cosine of x being squared also. So this simply means you have got two brackets of the sine of x being squared, the sine of x plus 1 into the sine of x plus 1 like this. All right, over the cos that we have. But if we check on our answer, we do not have a cos. Let us be honest here. On our answer, we do not have a cos. There's a sine. So meaning to say we're going to think of changing this cos to a sine. How is that possible that a cos can be changed to a sine? Remember from our Pythagorean identity, cos squared x plus sine squared x is equal to 1. So in order for us to have cos squared, we're going to transpose this to the other side. So that will be having cos squared x is equal to 1 minus sine squared x. So that means in place of cos squared x, I'm going to write 1 minus sine squared x, of which that is not enough again, because we still do not have what we want. Okay, but this is a special type of a trig that we have. It's a difference of two squares. Remember from our difference of two squares, we agreed that a squared minus b squared is going to give us a minus b into a plus b, as long this is being raised to the power of 2. 1 here is same as 1 squared. So it's the same as we have a squared minus b squared. So it means we are going to have the sine of x plus 1 like this into here. We're going to have the sine of x plus 1, everything over what? Everything over the difference of two squares of 1 minus sine x, because the same as a squared minus b squared, which is a minus b, a plus b. So it is going to be 1 minus sine x into 1 plus sine x. Remember I said sine x plus 1 and 1 plus sine x is the same. So you can cancel here, these two are the same. So we are going to remain with sine x plus 1, of which sine x plus 1 is same as what? 1 plus sine x. Everything over what? 1 minus sine x. And this is exactly what we have on the right hand side. So this is what we have, 1 plus sine x over 1 minus sine x. So identities, guys, know your identities. You are supposed to know your identities, how to simplify. So this is directly equal to what we have on the what? On the right hand side in this case. So let's just write is equal to the right hand side. All right, just for simplification purpose, but this is not even important. All right, so let's see. Another question. I think we were writing down. So we're writing down, so it's on top. That's question number 6.2. Calculate the values of beta that will satisfy the following equation from beta being 0 to 360. All right, that's okay. We talked about this one. Okay, this one I think is just direct. I've got a cos and a sine. We just need to write this as a single trig, and the best single trig that we have, if we have a cos and a sine, is to think about tan, because we know that tan of beta must be equal to the sine of beta over the cosine of beta. We are supposed to think about this. So in order to have sine over cos, we can divide by cos. So you're going to divide by cos beta here, going to divide by cos beta here. So this will cancel. So meaning to say we are going to have 5. Remember I said this will give us a tan. So we're going to have 5 is equal to sine over cos, which is tan. So we've got sine beta here over cos beta, which is going to give us a tan. So this will be 2 tan of beta like that. So in order to remain with tan, we're going to divide by 2 by 2. That means the tan of beta is going to be 5 over 2. All right, but this is not our answer here. This is the decimal or the fraction which gives us the tan of beta, but our beta is taken from 0 to 360. So we're going to consider to say, all right, our tan beta here is a positive. So it means we are going to be considering the quadrant from our all students take calculus, or the cast concept. All students take calculus. We're going to see that tan is positive in this quadrant and in the first quadrant. And we know that in the first quadrant, from the reference angle, the actual angle, which is our beta, is going to be equal to the reference angle. In the second quadrant, beta is going to be 180 degrees minus the reference angle. I talked about this on the trigonometry introduction. Beta is going to be 180 degrees plus the reference angle here. Our beta is going to be 360 degrees minus the reference angle. What is the reference angle? The reference angle is the one that you obtain if you find arctan of 5/3. So you're going to have arctan of 5/2. I mean 5/2 like this. You obtain what we call the reference angle. Then you find the actual angle, this one. This one is your actual angle, the one that you're going to consider in terms of the quadrant. If they say tan x, this will be x, this will be x, this will be x, this will be x. If they say tan theta, you do the same, but here they say tan beta. So our actual angle will be written in form of beta, but we need where tan is a positive. And I said where tan is positive, it's in the first quadrant and in the third quadrant. So if we now consider the first and the second quadrant, that's where we can take our answers between 0 to what? To 360. So let us have our reference angle from our calculator. All right, remember I said the reference angle simply means arctan of this part that you have. If it is a negative, don't use a negative. The negative simply represents the quadrant. So here, I'm gonna need this part. All right, so let us see from our calculator. Like I said, we need arctan of the reference angle, which is arctan of this fraction here. So it's gonna be shift tan like this of 5/2. All right, so that's 5/2 like this. That is going to give us a reference angle of 68,199 in this case. All right, so that's 68,199 degrees like this. All right, so that's our reference angle, not the actual angle, but the reference angle that we use to find the actual angle. So the actual angle now, which is beta, in the first quadrant, beta is equal to the reference angle. So our beta is going to be equal to the reference angle, which is 68,19 degrees. And the other beta, or you can just have, or another beta is going to be given as, in the third quadrant, we say tan is also positive there. And the actual angle is given in the third quadrant as 180 plus beta. 180 plus the reference angle. So our beta is going to be 180 plus the reference angle, which is 68,199 degrees. So that means our beta is going to be 180 plus 68,199 like this. So this is going to give us 248,199. So it's 248,199 degrees. So these were the possible values of beta in the interval that we are given from 0 to 360. Within this interval, that was the best. These were the two possible answers that we could have obtained, beta being equal to 68,199 degrees, or beta being 248,199 degrees. All right, so that was 5 marks for that. But 5 marks for this, which is fine. That was fine. 6.3, we are given, consider the fig 2 that a man was walking towards a nearby building. So we're given a condition of a man walking towards a nearby building, in this case, where he decided to stop at point B, in this case, through the angle of elevation B and so forth. All right, so the question is that we are given that BCD is a straight line, and from this part, we are asked, determine the height of AD. All right, so that is the first question, determine the height of AD of the building. All right, let's see. This is our trigonometry, guys. We are supposed to play around with the angles that we are given. We do not have anything from this side here, like the length from A to D here. We do not have anything. Also here, we do not have anything. So it's going to be difficult actually here. Okay, so if we consider our information, we're just given that here we've got angle 54, 1,8, and 67 degrees. So meaning to say you are supposed to play around where you have the length, which is on CD. You are supposed to play around with the triangle, with this triangle, this one. So if we use this triangle, we can apply because this one is a non-right angle triangle, this one that we have. Remember here it's 67. So we are going to play around this triangle. That is where we have information about the length. Remember, we want to calculate the length. So if at least we can have this length of AC, it's much better because we can use the right angled triangle now to calculate the length of what? AD. So this information is limited on this triangle. So let us focus on triangle using triangle ACB. Triangle ACB. All right. So you're gonna find the angle here at C from 180 degrees. These are angles on a straight line. So it means angle ACB or angle C is going to be 180 degrees minus 67 degrees. All right. So from our calculator, let us see what we are going to have here. 180 degrees. So you're gonna have 180 minus 67. That will be 113 degrees. So you're going to obtain 113 degrees on this angle here. So we can find this angle at A, the one opposite to the side that we are given. So meaning to say the angle at A inside this triangle is simply going to be from 180 degrees, 180 degrees minus the two angles in this triangle, which is 113 that we got, and the 54. So you're going to add this, subtract from 180, that will be 13 degrees. All right, so you've got the angle A is going to be 13 degrees. All right, so using this triangle A, remember you're supposed to calculate AD. The question is to calculate the length of AD, but we can calculate AC first. So we are going to calculate AC. How are we going to calculate the length of AC? This triangle ACB that we are using, it's a non-right angled triangle. This one, it's a non-right angled triangle. So we are supposed to think of the sine rule in this case. All right. So I don't want to bring confusion to you about the sine rule, because if you check, most of us, we prefer to use what the formula sheet brings, but the sine rule can be written in a way that you understand. Here they gave us the sine rule in this format of the angles on top. Sine of A, this is what most of us want to use as it is. Let me just use as it is so that you also understand. From that sine rule, it follows that the sine the angles are the ones on top. So it follows that the sine of A over A is equal to the sine of B over B, which is equal to the sine of C over C, whereby you're considering the angles A, B, and C, these ones. The capital letter is the angle. So you must have it on a condition whereby the angle corresponds to a side like this. Like this part that we want to calculate AC. So AC corresponds to the angle of 54 degrees. 54 is opposite. The opposite concept, 54 is opposite to AC. So it is going to be the sine of A, which is the sine of the angle there, 13 degrees, over the corresponding side, 1,8, must be equal to the sine of what we want to calculate, which is the sine of B, of 54 degrees over its corresponding side, which is the side here that we are supposed to calculate, which is what? Which is AC. So we have formulated an equation. We cannot consider about, yes, if you want to calculate, you can also calculate AB if you want. Yes, you can calculate AB. You can still obtain the same answer from AB. There you can choose, because you can also use the bigger triangle of this one if you calculate AB. But since here I'm gonna consider AC, so we're still gonna have the same answers at the end. So to find AC, let us cross multiply here and see what's gonna happen. AC times sine 13, it is going to be AC, the sine of 13 degrees equal to 1,8 times the sine of 54 degrees. Okay, so to find AC, we're gonna divide by the sine of 13 degrees, both sides, by the sine of 13 degrees. So that is gonna cancel. We remain with the length of AC in this case. All right, so this one is going to give us what? So like I said, we started by AC. So let us see from our calculator, what are we going to have from AC as a fraction? 1,8, the sine of 54 degrees like this, over the sine of 13 degrees, over the sine of 13 degrees like this. So that will be 6,4. So we're gonna have our length here of 6,477 like that. All right, so we have got 1,8, the sine of 18. All right, we've got two angles that we're gonna consider here. So like I said, we are considering AC. You choose which part you want to work with. All right, so meaning to say this will be 6,474 6,474. The units there are in meters. All right, so that's for the length AC. So if you wanted to calculate for the length of this one for AB, if you wanted to AB, it was going to be the sine of 13 degrees over its side, which is 1,8, is equal to, in order for you to calculate AB, you're going to use the sine of C, which is the sine of 113 over the side AB. So it's going to be equal to the sine of 113 degrees over AB. So there you calculate AB. All right, but here we calculated AC, so we're gonna use this part now. AC, it's 6,4. We're gonna have here AC 6,474. So if you calculate AC, this one, you're going to use the inner part of the triangle. We are going to use the triangle that is inside this one. That is from A to D, it will be at 90 degrees. And here we've got 67 degrees at C. So this is our AC, which is 6,474 meters. So how are we going to calculate the length of AD? This one, this is our AD, which is the height. So according to this angle, this is our opposite, and this is the hypotenuse. So you're going to apply the trigonometrical ratios, because this is a right angle triangle. From our trigonometrical ratios, we can calculate AD now. So here we can now calculate AD. So that is opposite, and hypotenuse, that is from sine. Remember from our SOHCAHTOA concept, opposite hypotenuse is on sine, which is the sine of theta is equal to the opposite over the hypotenuse in this case. That is the sine of theta, the angle of 67, is equal to the opposite, which is AD, that we are supposed to calculate, over the hypotenuse, which is 6,474. So you can cross multiply here to find AD. So that is cross multiply. 1 times AD, that is going to be AD is equal to, multiply this side, is going to be 6,474, the sine of 67 degrees, right? So there we can obtain the length of AD. We can have the length of AD here. So let us see what you're going to have at the end. That's 6,474 like this, times sine 67 degrees. All right, like this. That will be 5,9593 and so on. So it's going to be 5,959. Okay, so you're going to have 5,959 meters. Remember, the units there are in meters. So that was the length of AD. So even if you use or you work with AB this side, you're going to have the same thing. All right, so I want you to prove that. Can you use AB? But in order for you to obtain AD, when you use AB, you are going to use the angle of 54 degrees. You are not going to use this. You are going to use the bigger triangle to calculate AD. You are going to apply or to use what? The bigger triangle. All right, let me just remove this. So you are going to apply or to use the bigger triangle. I just want you to calculate that one and do it on your own. So you'll be having your AB, this one, and this is your D. You're not going to consider this part. So you're just considering the angle at B as it is, which is 54 degrees. And the side AB that you calculated from here, remember, you're going to use this. And with that, you can calculate AD. All right, so I want you to try and do that and see if you're obtaining the same answer. Question 6.4, you're given Fig 3 is a defined f of x, which is in this format. We are given f of x is equal to a sine bx. So this is our f of x here, which is this one, which is given as a sine bx, and gx, which is cos x plus c, cos x plus c. All right, so that was our graph. Determine the value of a, b, and c for values from 0 to 270. So you need the values of a, b, and c from 0 to 270. If we consider from 0 to 270 in this case, all right, our graph here. All right, take note, this is the graph of sine, and from our normal graph of sine x, this is what, guys, you are supposed to know your graphs. From the normal graph of sine of x, it is like this. It passes through 0, that's at 90, at 180, at 270, at 360 degrees. If you check the half of this graph here, the half of this graph is at 180, and the maximum value is at 1, which is the maximum value here, it's at 1. So meaning to say this is a normal graph of sine x that we know y is equal to the original sine x, not sine 2x, not sine 3x, original sine x. But here it's given as f of x is equal to a sine bx, a sine bx, like this. So a being the maximum value here, which is 1. So meaning to say a is equal to 1, b being the value here that is affecting x. And here there's nothing that changed from our original graph that we know. So our b is going to remain as a 1. Nothing changed. All right, but if we check the graph of cos now, it's given as cos x plus c. All right, the normal graph of a cos, we know it this way. This is the normal graph of a cos. We know that it starts at 1 like this. This is the normal graph of cos, whereby this is 1 at 0, and we've got 90, 180 degrees, and so on and so on. But if we check on this graph here, it is not starting at 1, it is starting at 2. So what is the value of C representing? It is the value that shifted from our normal graph that we are supposed to have. Now it's starting at 2. So this graph here has shifted 1 unit up. It has shifted 1 unit up from 1 up to 2. So meaning to say, we are having our graph as gx is equal to the cosine of x plus 1. At cosine of x here will be at 1. So it will be 1 plus 1, which gives us a 2. So C simply indicates what? C simply indicates a 1. So, okay, guys, this was something that was just direct in this type of a question. I just hope as we move on with our trigonometry revisions, I shall also talk about this as a separate thing, as a separate topic, like as a separate section that we can at least consider finding of these unknown values. I considered, if you check the video on the trigonometry, I talked about sketching of these graphs, but we need a condition now where they sketch for us like this, then we reverse it to the normal way. So you take it from that normal way that we are used to, or you can use formulas. There are formulas that you can use, but here you could have applied this concept of your original function. Well, how does it look like the graph of sine x? So you're supposed to know how does the graph of sine x look like? Where do you take your values from to? And also the graph of cos, so that if it is shifted, they can shift it down like this. You are supposed to know what is happening. Or they can even shift the graph of sine on top like this. You are supposed to know it starts at 0. When it is shifted to 1, it means we must have it as sine of x plus 1 because it has shifted a unit, 1 unit up, depending. If it is at 5, it's going to be 5 minus 0, which means it is going to be a 5. So you need to know each and every graph. All right, so that was it, guys. 100 marks full paper. All right, so just hope you'll be able to collect these marks on your final exams with these revisions that we are having. So like I said before, this is a sponsorship that we are having from our members. So let us also become part of the members. This also helps us a lot. It supports us to be able to have videos of this nature in the future. So the moment you join the membership, it helps us a lot, guys. So please make sure that you join the membership, and also to share our platform to our colleagues and friends. Let them also be part of this channel, or be part of our membership program, so that it helps us to produce more videos as we move on towards our exams. So that was it, guys. August 2023 exam.